Hi, welcome. This week we are going to start a new chapter, and in this module, actually, we are going to discuss about the databases. So, we are going to understand the data storage systems all across the IT systems. Um, I mean, online, offline, we will see, but databases are the is a topic that you cannot avoid it whenever you discuss IT, software engineering, so those information technology related fields, databases are kind of very essential in every places. So, there are a lot of advancements going on in the field of the databases as well. People are inventing new ways to access data from different databases. So, we are going to discuss about it in this chapter. And our discussions will mostly be focused on introductory concepts. Like other weeks, here also we will start some interview simulation regarding the purpose of this module. So we are talking about the database management systems. The question is, what kind of databases do you commonly access in your everyday life? So anyone that performs a Google search, what are we searching? From where are we searching? Have you ever think about that? So that is the thing that you should consider when we talk about the databases. So the data is stored everywhere. The Google search facilitates you to search all those databases to get you the appropriate information that you are looking for. Now, those databases can be very structured databases. They may be some documents. They may be scattered around different places. So everything all together, we make a common buzzword called the databases. In this module, we are going to learn about how to interact with the database. We will identify the principal components of the database. We will talk about the functions associated with the database, or how does a database function? What are the functions that database perform? How do they perform? We will define the relational databases. This is a new word for many of you. Don't worry, we will talk about it. Discuss how to use a database system. We will explain how we can organize data in the database. We will also explain how to set up a database. We will see that it's not a very rigorous task to set up a database on your personal computer. We will also explain how to ensure database integrity and how to use the data responsibly. The computers that process data in a database they generate information for users. Businesses use databases to track information over time. Let's say you have or you are running an e-commerce store, or rather than you, I can tell you, like, let's say we have Amazon running their store, the online e-commerce store. Every one of us knows about that Amazon Prime, all those things. You place an order on Amazon today, and from 1 year from today, you can still track the information, like what what was the amount you were charged when you placed the order originally, when it arrived to you, and if there is any other suggestions Amazon could provide you, the similar type of things, all those things actually. So Amazon could use the databases to track information, your information. They can see that you bought a some kind of thing, some kind of gadget. Let's say you are a pet owner and you bought a waterproof jacket for your dog in in spring, then they are going to track that information for their business, and then they can recommend you other pet products over the time. Let's say it's summer and they can ask you to buy some summer gadgets for your pet, maybe a swim swimming accessories for the pets. In the fall they may ask you about something different, like a lot of leaves on the ground, so they may ask you to buy a pet sock. So all those things, a retail business may use a database to store customer information, details on sales transactions, on or an accounting of inventory in stock. You say, let's say you have a guitar store. So in the guitar store, they may use a database to store their inventories, what kind of guitars they have, what are the subtypes of the guitars, how much do they cost, if there is any promotion, all those things are can be stored inside a database. A healthcare office, your doctor's office might use a database to track our medical histories. Let's say I have some disease, I visited doctor for some issues, some health issues, and they will recommend us based on my health information what's good for me. Maybe they will give out some free advices. Maybe they will offer certain products to to be healthy. I mean, things like that. A database at school contains data about the students and classes. So when you generate your transcript, basically, what do you think where that data comes from? It's basically data from the database associated with the school systems. Next question is, why do we use a database? The answer is pretty simple. The data is crucial component of most organizations, and databases organize the data. Databases make it easily accessible whenever we need some data, and they ensure that data is kept safe and secure. The documents and spreadsheets store information, and it is isolated from the information held in other documents and spreadsheets. Databases offer the advantage of showing connections between different sets of data. A database management system or database program is a software that allows you to create, access, and manage a database. Users will be able to add and delete some data. They can sort and filter the data. They can analyze the data to detect patterns and gain other insights. Let's say you are doing some IT projects on behalf of a retail company that sells the clothes. It may be helpful to know the preference of the clients, preference of their customers over different regions. Let's say in the West Coast, the customers prefer certain kind of outfit, whereas in the East Coast they prefer certain different kind of outfit. So I mean, those informations are crucial to the business, so they can analyze those information and they can reinforce their business practices or products or the policies based on certain regions. Users can sort the record in the table according to the contents of one or more fields. And I mean, we often do the sorting using um, some dates, for example. Let's say we have a record of the different things. I mean, let's say on your travel website, on your let's say you are a member of a travel site, and you book their tickets from there, and you can go to your account and you can see the past reservations, and that those reservations, they are contained in a table, and you can sort them according to the date, maybe the ascending order, maybe the descending order, to see uh, when did you travel and what is the pattern that you traveled. Users can sort the records in a data in a table in alphabetically by at least by last name, or numerically by, let's say, zip codes. A primary key is the field that uniquely identifies each record in a table, such as student ID. So whenever you talk about a database, you have multiple records in a table. Think about an Excel spreadsheet. You have 100 rows of, let us say, your your data. Maybe that data is based on what are the transactions you have done with a certain store for past 100 days. Now each record should be unique, right? I mean, otherwise each record means each row on your spreadsheet should be unique. Otherwise, if you deal with redundant rows, duplicate rows, then you end up wasting a lot of time. So how do you ensure that your each row is unique? So that's why there is a way to create that record with a unique field for associated with that record. That can be a simple number, that can be a alphanumeric character, whatever. I mean, but that should be unique across the whole spreadsheet or whole data table, and that is called primary key. If you think about a student record, then the student ID can be treated as a primary key. In the United States system, the social security number is the primary key, kind of primary key for people, right? I mean, each people is different. Their records have a common pointer, that is social security number, which is pointed to their tax record, their medical record, their school record, and so on. File processing systems and database approach. Let's discuss about that. A typical file processing system, each department or area within an organization has its own set of files. The records in one file may not relate to the records in another file. A database can be a little bit more complex than a file system. People with special training develop larger databases and their associated applications. The database systems also require more memory and processing power than the file processing system. The main weakness that we can mention about the file processing systems are twofold. Namely, number one, let's say number one is you may encounter redundancy, the data redundancy. So same thing is repeated every many places. Let's say you have 5 files, and if you store five, I mean, in the 5 files, if you store group of information, they are same. I mean, maybe you keep same information in multiple files. So that's the redundancy, data redundancy. And also you can have another thing, that isolated data. I mean, your file number one and file number two may not be very much related. So there is no way to establish a relationship between files. That's a major weakness of file processing systems. But still, if your data is so compact that you can handle it using a file, then file processing system may be um, an example of a good database. For example, let's say you are exchanging information between two systems. You are integrating a in your school. Let's say you have a um, like enterprise processing system, ERP. You have PeopleSoft, and then maybe there is a payment processing system, and then you may have a refund. Then the payment processing system can exchange that refund information with an associated payment vendor so that they can issue you the checks, and those information can be shared with simple flat files, CSV files, comma separated files that can be read through the Excel spreadsheet for your information. So those can be shared, those information could be shared securely with a payment processor so that they can create some check for you to refund. But that's also a file-based system, but in this case it is appropriate because you just have certain small subset of information from the student and payment for that purpose. The database approach is much rigorous, much comprehensive, and it's a larger approach. When a company uses a database approach, many programs and users share the data in the database. The database secures its data so that only authorized users can access certain data items. The database approach addresses many of the weaknesses associated with the file processing systems. So, what are the advantages of the database approach? Number one, it reduces data redundancy, it improves data integrity, it shares the data, and it provides you easy access to the data. So everything is programmed. You don't have to open file manually. Even, I mean, behind the scene, there are programs associated with the database systems that will automate a lot of tasks that you do with the files. On the top of that, you could establish relationship between the data, and that way you can have improved data integrity. You cannot delete certain data which is required, which is related to some other database tables. Now, this picture you can see that network can share the resources and the data, so you can see the complete database at the center of this diagram. And then you can see that this complete database can be shared through network with the housing office can access the student dorm and room assignments. The registrar office can access students' course information. So you have the student database, that is the complete student database. You share it in housing office, at the registrar office, and also at the financial aid office. Now, from the same database, same information, there can be different domains, different perspectives. Housing office accesses the dorm and room assignments. The registrar's office can access students' academic information, course information. The financial office will be concerned with students' financial information. So if you can share the database or by the network, then different other uh, systems can use that data with their requirements. A database service or a website that acts as a portal for the database enables government agencies, schools, and companies to share information with a wide audience. If you go to Internal Revenue Service, you will see that they maintain portals for certain things, certain forms. And then the main advantage of using the portal is that the main advantage of using the portal is that you can use those information across the different systems. Now there can be some public databases as well. That includes the examples include shopping database, travel database, and so on. The other databases contain information accessible to authorized users only. Um, if you want to access the information, let us say Social Security Administration, they also have a database. I mean, they also maintain databases, very important databases, very sensitive databases. So those information can only be accessible to the individuals that has a valid account with the Social Security, their own information, or maybe some administrator but they have certain roles in the system. They are authorized users. The examples of protected databases include certain government databases, entertainment databases, and research databases. So if you think about entertainment databases, when you go to the website IMDb, you will see a lot of movie related information. If you go to for the research databases, let's say if you go to the Center of Disease Control CDC website, you will see a lot of information regarding different diseases. So they in each of these organizations they maintain databases so that and they protect those information so that those informations cannot be compromised or no misinformation is propagated to um, the users and so on. Web database services can provide access to information about the government as well as information created and used by the government agencies. This also enables officials around the world to share the data. A subscription-based entertainment web database service allows you to access media content such as music, often enable you to create and share playlists. Booking online travel through a travel web database service enables you to view multiple vendors and options. Now, these database services can help you to find deals on air travel, car rentals, hotel rooms, and vacation packages. I'm talking about the online travel databases. Shopping database services enable you to locate the right size and color, sort by price or featured products, and more. Vendors can use a web database service to show photos of items they sell and to track inventory. In this set of slides, we are going to discuss about database components. So, in that context, an Axis navigation pane is a pane in a program window that lets you move between the objects such as tables, queries, form, and reports in a database. For a community college, let us say, a data file called a table in Access is a collection of related records stored on a storage medium such as drive or on cloud storage. The sample database shown in this module contains tables and important information related to the students and instructor information. So in this database, this is based on Access database, which is a Microsoft product. So we are talking about Access database, and this is a Microsoft product. In a Access database, I mean, you don't have to be confined with the Access database. This is an example of the components. So you use any kind of database, there will be some kind of navigation pane that can let you move between different objects in the database for I mean, this is a database related to a community college. This is an example, like you can see there are different tables in that database like classes, department, enrollment, instructors, sections, of course, the students, and so on. There are queries. You can have certain queries, you can have forms, you can have reports. I mean, this is a structure which is specific for Access database. A data file that is called a table in Access is a collection of related records stored on a storage medium, such as a hard drive or a cloud storage. The sample database in this module you can see that contains tables and important information in relation to the student and instructor information. Like, for example, classes, enrollments, instructors, sections, and so on. When you talk about the database, the the main parts of a database system that stores data are characters, field, record, and table. There are other database objects. We are speaking in relation to Access database. So the Access database contains records, forms, and queries. They are based on the data stored in the table. In the ASCII coding scheme, each byte represents a single character, which can be a number, letter, blank space, punctuation mark, or any other symbol. When we talk about the database, you will often encounter the keyword called fields. A field is a combination of one or more related characters or bytes and is the smallest unit of data in user data a user can access in the database. A field name uniquely identifies each field. The database uses a variety of characteristics such as field size and data type to define each field. The field size defines the maximum number of characters the field can accommodate. A typical set of properties for the field, for example, the instructor ID fields, can you can see here in the table on the right hand side of this slide. I mean this table, you can see it has a limitation of the field size, its format, the input mask, the caption, that is instructor ID. It does not have any default value. It has a validation rule that it should be between 30,000 and 50,000. Validation text, please enter a valid instructor ID. So it is required field, and allow zero length is not an option. Um, it's indexed so that there is no duplicate, uh, and so on. Now, a record, for example, a database, I mean that contains the tables, mostly the tables, and there are other objects as well inside the database. But when you talk about the records, let's say there is a table in the database like this. So a table contains rows and columns, right? These are horizontal things are rows, and the vertical are the columns. So you have the row, each row represent a record. Let's say this table contains three records, 1, 2, and 3. So it has three different rows, 1, 2, and 3, and it contains different records. And each column represent a field in the each of the columns. They represent a field in the database table. A student record includes a set of fields about one student, including the primary key field. So what is the primary key? Primary key is the primary identification key for the database table. The primary, in order that a field can be a primary key in a database table, is that that field should not be null. That's not nullable. Not having a null value for the field is not an option. That's number one. And number two is you it has to have some scheme to be unique. Like for example, I am inserting some value inside a database table, and the primary key can be set as auto incremental, meaning I don't have to do anything there, but the value associated with the primary key will be incremented automatically. That's number one. Number two is it should not be null. And then when in certain databases like MySQL, if you if you call a key as a primary key, then it will be automatically indexed by itself. So indexing, we'll talk about indexing later, but indexing is related to the searchability, or the how easily you can run a query in the database. So when you have an index like a book, I mean, if you have an index, it is easier for us to find the keyword within the book. Let's say you have a 1000 pages long book, and then you want to find out the keyword Java. Then you go to the keyword search, the indexes, and then you find the Java, and then it will tell you that which page numbers contain the word Java. Then your search can be limited to those page numbers. So index does the exactly same thing for the database. When you say some field, some generate some index, assign some index for a field, then it will be easily searchable. A table, in case of, so we understood the records, right? That was our main purpose. The record is, each row is a record. In principle, a record is a group of related field, and it's a it's related to the content of the database, the unique records. Database table has 5 records, means there are 5 different information you can get from this database. The tables, when you talk about the tables, that is the highest level in the data hierarchy, as it contains fields and records. So table is a combination of rows and columns. So you can tell it as fields and records. Fields means the columns, records means the rows. The student table at a school might consist of thousands of individual student records. I mean, if the table that I created, that I drew here, it may be a student record, student table, and this table can contain 1, 2, 3, all the way to thousand, 10,000 of records. Each one represent a student, and each student record represent the same set of fields. That's important. Each student record contains the same fields. Each field, however, contains the different data. So the student ID will be different for different students. Student name, let us say, if that is a field in the student table, then the name can be different. I mean, but two students may have the same name, but their other attributes are different. So that's why we talked about the primary key or ID field, because that will at least differentiate between one student to another student, or one record to another record. So when you think about the database, you have a database that contains the records, okay? And then the highest level of the data hierarchy is the table. A table contains certain rows, that means the records, and columns, those are the fields. So each row contains same number of columns, but the values the value of the data stored in these columns, they can be different. In fact, for different rows, the each column should constitute a unique information. So each, for a student database, you can have 10,000 students in a school, and if there is a table called student, then each row of that table should represent one student. So if you have two students, let's say John, John Doe and Jane Doe, they should not be mixed up. Like there should be two different records. And also John Doe cannot contribute to two records in the table unless there are two John Does with the same name, but their other attributes must be different. That's why we need the primary key. Whenever you add a student to your school system, they will be assigned to a ID, that is the primary key of the database table, and that's how you will recognize that this guy is the John Doe and this ID is this John Doe, versus there are five more John Does but their IDs are different, so there are five different students. Now comes the queries. The whenever you have the database, you have to extract the data out of it, right? Then otherwise, what's the use of it? So in order to get some information, in order to extract some information from the database, the tool that you have to run is the query. Like for example, you talk to some person, you ask them some question to know some information that you don't know. So queries is something like that. You want to know details about any records in the database. So that's why you need to do the queries inside the database. So the query is an important part of the database. Now, when you run the query, then that query in fact extracts data that helps you to extract query. Actually, this is a tool that extracts data from a database based on specified criteria or condition for one or more fields. So whenever you talk about the student database, let's say you can write a query, like you can ask the database in specified language that give me the names and let us say the classes attended by a student whose student ID is 12345. That means it will go to the database, it will go to the students table and fetch the data for the student ID equals 12345. Now, sorts and filters are utilities when you working with a single table. However, most of the work users perform in a relational database requires working across multiple tables. So we have uttered another buzzword, which is relational database. What is it? So in a database system, you can have multiple tables, right? You may have a student table in a school database system. You may have a student table. You may have an instructor table. You may have a classroom table, class table, and so on. Now, in the class table, for example, a class may have more than one, a class may have an ID, right? So a student may be enrolled in multiple classes. So, a student ID can be pointed to multiple classes. So in the class table, in the class table here, you can have a pointer to the student ID, and then whenever the student enrolls in a class, it will create a row inside the class table. So this type of relationship that you can see here clearly, that there is a relationship between the student table and the class table. So whenever database is designed to behave like that, then you call that database to be a relational database. So relational, the word relational comes from relation. So two tables are related. That's why you call them a relational database. Sometimes, in the database experts or database engineers' own language, a table can be themed as a relation. So sometimes you call relation, whenever you call relation, you may mean a table if you are a database personnel. Okay, so whenever you have a set of tables and they are interrelated somehow, not every table is related to every other table, but there are relationships between one table and another table so that you extract the total information. So why do you need the relationship in the first place? What do you think? Tell me some reasons why the people who develop the databases set up the relationship. The answer is pretty simple, you know. We initially talked that the database is a pretty complex system, and whenever you need non-redundant data, means no repetition, no like there is a redundancy, right? And also absolutely absolutely having high level of integrity, then you need a relational database. That's why you need to establish a relationship. So in this case, you can see that a student can have multiple courses. So do you think that the student database for each student you have 1000 rows? If they let's say each student have let's say not 1000, that's too much, but each student should have 30 30 rows, because a student is enrolled in 30 different courses. How do you represent that? So that's why, I mean, if you don't have any table other than the student table in your database, then you probably won't need any database system, and you will have 30 records for on the student record for the same student, which we do not want. We rather want that a student should be a student, that's the actor in the system, another actor is a course, so there are two different objects in the system. Then one student object may be related to multiple course objects, because you know, I mean, I can enroll as a student, I can enroll three different courses during this semester. So uh, my identity will be stored in the course tables against three different courses. So basically, what you do here is that you have a student table, you have a course table, each record in the students table is a student, each record in a course table is a course. So if I can establish a relationship between the student table and the course table, then I don't have to repeat anything in any table. In the course table, you don't have to repeat the same course multiple times. In the student table, at the same time, you don't need to repeat the same student multiple times. You have the database to do that job. Okay? So that's why you use the relational databases. Now comes the important information about the forms. To reduce the data entry errors, well-designed forms should validate data as it is entered. So it is like a gatekeeper in the access database system, you know. So you use the forms to validate the data. It's like, for example, if you have a website, then you enter the data. Let's say you enter the your social security number on the Department of Motor Vehicles website, and by mistake you wrote some misdesigned, misformed social security number. By default, social SSN should contain 10 characters, numerics, 10 numerical characters, and you by mistake used 5 characters. Then that is the form validation. You know, you entered that information, submitted that form, and then the form will run a separate program that will validate your entity. So in the access database, this form is used for exactly the same purpose, and then the validation goes. So it determines whether the data is good enough to be saved into the database. A visually appealing form or a data entry form where each field is spaced out on the screen makes it easier to interact with and understood. So that's kind of form. I mean, it's like your physical form, the paper form, sometimes you fill out, right? When you go to the DMV office, you have many options. One of the options is write a paper form, then someone helping you at the counter, the employee, the DMV employee, they will extract your information from the form and then type it into the system. The form should be easy to use and navigate and provide relevant information about the data. A form provides a data entry screen that generally shows only one record at a time. This is true for Microsoft Access. Then comes the report. The database users can collect data from the database with the intent of communicating this information to other people. So that's where the scope of the reporting. So in order to facilitate that workflow, like you communicate certain records to people, you can generate a report to a web page for easy access via the internet. So if you think that let's say you have a hospital, then you generate a report every day about your inventory. So whenever, I mean, in the subsequent way, I mean, the report can be used to see how the things are going related to the field of the report. Let's say it generates a report about the patient accounts. So then from that report, they can easily see which of the accounts are paid, which are not paid yet, which are overdue, and which are, I mean, at a high risk so that they can initiate handing it over to the collection agencies. You know, there are a lot of different reports can be available within your database. Now, again, the reports facility we are talking here, this is about the Access database. But with other databases, you can also have the equivalent tools. Okay. Now comes the data type. In order to ensure that the data in a database has integrity, fields must have the correct data types. So the data type specifies the kind of data field can contain, um, how the field is used. You can define a field as an integer versus you can define a different field as a double. I mean the decimal, let us say. So in these two cases, the field types are different. Let's say the integer field, the field that is integer is used to enter number of items bought or sold if it is a product database. But then the another field which is type decimal can be used to hold the value of total transaction in dollar amount. And then there can be another field, you know, there can be another field that is of type character or text or string or Bharkar. We'll see what Bharkar is later, but that's a variable number of characters. So when you do that, um, basically you can store that Bharkar to store any text. So if you have a field called the product name, Bharkar may be the appropriate type for it. So again, the data type specifies the kind of data a field can contain and how the field is used. So you can see on the right hand side here, there is a report generated for students grade listing, and you can see here that the course name is there, and then the I mean course name is there, different class name is there, the student ID, student names are also there, and the grade value is there. So first field is the course name, the details. Second is the course code. Third field is the first name of the student. Fourth field is the surname or last name of the table of the student. And last field to the right hand side is the letter grade obtained in that course. So this is a report. I mean, that way you can create a report. If you have to, in order to generate a report, you have to define the field, you have to define the format of the report. There are some reports that are generated in Excel spreadsheet, in form of Excel spreadsheet. You may want to send it by email to your clients or anybody that needs that report. You can create a report so that it is stored every time it runs in a specified area on the disk, so that this can be reused multiple times. It can be sent to the customer, and then you also keep a record of that report, so any times later some issue comes up with anything related to that report, you can always refer to the original report that you have generated. So here is the time for our first discussion activity. You can say the discussion topic to be database forms are used to store data values. How forms are useful in evaluating students in the education sector. Okay, so this is an open question. You can initiate some discussions about this topic. Now we are going to talk about database functions. So the data dictionary uh, or the repository contains the data about each table in the database and each field in those tables. For each table, it stores details such as the table name, a description of the table's relationship to other tables, and the number of recorded in the table. A database management system or DBMS uses the data dictionary to perform validation checks to maintain the integrity of the data. For example, if you have a field which is integer, you cannot just enter a some other type like a date. You cannot enter a date value uh, to populate the table. When users enter data, the data dictionary verifies that the entered data matches the field that has a data type. Another function that we may require related to the database is the retrieval and maintenance of the files. The database management system can provide several tools that allow the users and programs to retrieve and maintain the data in the database. For example, you can find the records for a particular student in the student database, or you can enter a new student into the student database. The capability of querying a database is one of the most powerful database features. The more commonly used methods in order to retrieve and maintain data are query languages, query by example QBE, and the report writers. These are the different like methods in the Excel database. Sorry, the Access database. The query languages, you can see the QBE, query by example, and report writers. Another method is by importing data. You know, so what are the query language and query by example for the Excel database? Usually, all the databases use structured query language or SQL, which is a popular query language that allows user to manage, update, and retrieve the data. In the SQL, an example is given here on the to the right hand side. You can see That's how a SQL query looks like. So this one is an example of SQL query. You see, it starts with the select. So you are creating, I mean, retrieving some record. So you can see the class title, comma, class section, and there are different fields. And you say that from whatever the table, and you can establish the relationship, and then the filter is applied. And there is also a sort by or order by function as along with that. So the query language consists of simple English-like statements that allow users to specify the data they want to display, print, store, update, or delete. Each query language has its own formats and vocabulary. Most DBMS, database management systems, include a QBE. So again, the QBE is the query by example. So that is a feature that has a graphical user interface to assist user with retrieving the data. The report writer, in case of the Access database, a report writer or a report generator allows users to design a report on the screen, retrieve the data into the report design, and then display or print the record. Say you want to create a record of the students for certain things. Let's say record of the students that has a grade or the GPA, the grade point average of more than 3.5 for a scholarship purpose, let us say. So then you have a report, you have to generate a report. Now the report writers usually they allow you to format page numbers and dates, titles and column headings, subtotals and totals, the font size, some style factors. Some report writers allow you to create a report as a web page. Now comes another important function of the database, that is the user privileges, meaning a user, as a user, what can I do in the database? Most companies or organizations and people realize that data is one of their more valuable assets. A DBMS provides a mean to ensure that only authorized users can access the data. Most DBMS allow different levels of access privilege to be identified for each field in the database. Let's say you have a database of the customers, people in any database management system, and then that field contains the social security number. Guess what? This field may be prohibited to be accessed by any user in the database because that is a sensitive information of that person. Now, in Access database, the privileges define the actions that a specific user or a group of users can perform on the data. I mean, any database you should be able to do that, not just Access. The data in a database is encrypted to prevent unauthorized users from reading its content, and its access is restricted to only those who need to process the data. Some users have no access privileges to the data, that is, they cannot view or modify any data in the database. A database management system provides a mean to ensure that only authorized users can access the data. So that's why in the database they create different objects like permissions, roles, etc. to ensure that only authorized users can access the data. Another important function of database is the backup and recovery. A database management system provides a variety of techniques to restore the database to a usable form in case it is damaged or destroyed. More complex database management system, they maintain a log which is a listing of activities that modify the contents of the database. A DBMS or database management system recovery utility uses logs or backups and either a roll forward or a rollback technique to restore a database when it becomes damaged or destroyed. In a roll forward or forward recovery, the database uses the log to re-enter the changes made to the databases since last save or backup. A rollback or backward recovery, the database management system uses the log to undo any changes made to the database using during a certain period. Continuous backup is a backup plan which changes are backed up as they are made. So it's basically the changes. It backs up the changes. So from those changes, it can reconstruct a certain time frame when during the activities of the database using within a certain time frame. So these are all about the database functions. Let's do a quick knowledge check. Let's complete the following sentence. A repository is the same as a data entry form. A data repository, a data redundancy, a data dictionary. So we are talking about the repository, right? So four options: data entry form, data redundancy, data dictionary, and data validation. Which one is correct? As we discussed earlier, a repository is nothing but a data dictionary. So C is the correct answer. Okay. Now we start an important topic that is called the relational databases. Let's talk about the relational databases. As I said before, a database consists of tables. Now, if the tables are related among each other, not that you have to have relationship between every table and every other table, but if there are relationships between different tables inside the database so that you can constitute the the domain, the main uh, information within the database by establishing the relationship, then you can form a relational database. The main advantage, as I said again, as I said before, the with a relational database system, you can avoid redundancy and you can store the data more effectively, more efficiently. You can space a lot of storage because you don't use the repetition of the information, repetition of the records in a given table. Now, what is a relationship? So a relationship shows how the data in one table relates to the data in another table. That's how we define the relationship. The advantages of the relationship, uh, on the top of what I have already mentioned, that um, it can streamline the entry of the data into the tables. So in the over the entire database, if you establish relationship among tables, then this can streamline the data entry. This method reduces the quantity of data stored in the database by minimizing data duplication or redundancy across different tables. This reduces Another advantage is that this reduces possibilities of errors and inconsistent behavior or inconsistent states of the data. It can also make data updates much faster and easier to do so. Most importantly, it's not mentioned here, but if you write a software that interacts with the relational database, then it is much easier for that software to establish the object, the relationship based on the objects. So these are all the important features of the relational databases. Now, an example here, for example, this is a typical uh, college database. So in a college, you have different entities, right? So we are just describing some basic, very, very basic, very high level entities like you have the classes, you have the sections in the classes, then you have the enrollments, and then you have the students. So you can see here that there is a relationship between classes and sections. One class can contain lot of, more than one sections, and then each section can have one to many, many enrollments. There can be many students that can enroll into a section, and then a student, finally, everything is integrated back to the students because student is the main actor in this whole system. So each student can have multiple enrollments. So you can see here that the tables are related in a very interesting manner. You start with the class. One class can have many sections, one section can have many enrollments, and then one student can have many enrollments as well. So that's how your relationships are established. A typical relational database creates the relationship among different entities. So these are the entities, like we say the class, classes, sections, enrollments, students. They are called entities. Now, the relational databases forms the entities and establishes the relationship among the entities in this way. When we talk about the relationship, again, going back to the original representation here, the college database, you can see here that one class can have multiple sections. So this relationship is called one to many, you know. So one section have multiple enrollments. This is also one to many. And one student can have multiple enrollments. This is also one to many. But you have to identify which side of the relationship has the one, which side has many. So in this case, when you join or when you relate class to sections, your class part has one, whereas the sections part has many. Then if you join sections and enrollments, then your sections part has one, whereas enrollments have many. At the end, when you join students with the enrollments, your student part has one, whereas enrollments part has many. So it's really important to understand how they are related. Again, in the more formal way, we can describe a one-to-many relationship connects each record in one table to one or more records in another table. Just like one record in the class table can be connected to one or more records in the sections table. Why? Because, from the business definition point of view, one class can have many sections. It's just like that. Or one section can have many enrollments. So one record in the sections table can be related to one or more records in the enrollments table. A one-to-one relationship is more restricted. So when you talk about one-to-one relationship, you say like one record in one table is related to exactly one record to another table. An example here, you can see this figure, the student council president and elected student. A school student council likely has only one president position and only one elected student can fill that position. So there will be always a one-to-one relationship between, if you form a table like that, student council president and elected student, it should be like that. So we understood two types of relationship, one to many. Usually when you write in the language of database, you write it in terms of one, just one, the number one, and when you write many, you write n. When you create some diagram of the database, you usually write one here on the one side and you can write infinity here on the other side. Alternatively, you could write n here as well. That is also valid. The representation wise 1 to n, writing n in place of the many relationship, many part of the relationship is valid representation. So we understood one to many and one to one relationship within a relational database system. Now things can be even more complex. You can have two tables related in many to many relationship. So what does that mean? It means that more than one record on the left side of the relationship. So let's say there are two tables. This is T1 and this is T2. These are the two tables, T1 and T2. So many records in the on the T1 side can be related to many records on the T2 side. That is called many to many relationship. An example here, each student at a school, each student at a school can take more than one course at a time, right? You can enroll in more than one course at a time as a student, and each course will typically have more than one student in it. So that's how you define the many to many relationship. So here the left side is the student. So this is n, many student. So you have one student that can enroll in many courses, and also one course can have many students. So this is an example, typical example of a many to many relationship. So far we have understood three types of relationship. These are, if I just write it here, one to one, one to many, and many to many. These three are the basis of the relational databases relationships, the relationship matrices within the framework of the relational database management system. Now, you can have non-relational databases as well, like you have a flat file, you have a CSV file, comma separated file. So when you talk about non-relational databases, the enforced consistency of a relational database is an advantage. So the non-relational databases are often called NoSQL databases. They can resolve many of the weaknesses of relational databases. So if you have, for example, if you have some unstructured information, let's say you have lot of textual information, lot of text you have in your data. Okay, let's say uh, we are analyzing the Twitter comments and we are trying to extract the theme of certain set of messages. We want to classify the messages created by one person. Then the type of data you are dealing with, well, the person is a structured representation, but then on the other side, their message, that is a completely unstructured representation. In that case, in particular, the relational database system will not help you because it requires some structured form. But a person, what they can write at a given time depends on their mood, lot of things, like, right, I mean, their surroundings, their mood, what is happening outside them, I mean, so it's a non-relational stuff, and in that case, in those cases, non-relational databases really help. Now, there is a misconception that when you talk about NoSQL database, you know, the SQL is the structured query language. That is the query language of the database, relational, mostly the relational database systems. When you say no SQL database, then it means that it's not just SQL. It's not just SQL. It may support SQL, it may not support SQL. This is the way the terminology runs. So in summary, when you talk about unstructured databases, we can say that they use a variety of approaches to store many kinds of data. Now, with the non-relational databases, you can have some kind of key value databases, also called the key value stores. They create any number of key value pairs in each record. A key value pair consists of two relational items, one constant that defines the set, the key basically. You see the street address and then you have the value. On the table right hand side, you have the key as the street address as the key and corresponding value is this one. You have the city, corresponding value is that one. You have the state, corresponding value is that one. So you can have key value databases as well. A typical example you will see in future that when you create a JSON representation of your data, that can constitute a key value relationship. So in a JSON file, typical the terminology is JSON. Feel free to search the web with this keyword and you can say you can search for JSON databases. So basically JSON is a representation of data and that is a key value representation of the data. Now we are going to discuss about another next topic, that is how we can use a database system. With a DBMS or database management system, we can create a computerized database, add, modify, and delete data in the database, sort and retrieve data from the database, create forms and reports from the data in the database. I mean, creating the form, you may think like I'm talking about the Access database, but really I'm not. Uh, any relational database, let's say MySQL, you can you can always build a form to enter the data into the MySQL database. It may not be a part of the database system itself. Maybe it is like a application plus database combo. A variety of different database management system options are available, many of which enable a separation between the interface and the data itself and can support advanced queries. There are popular database management systems. A relational database management system is a software program where data is organized as collection of tables and relationship between the tables are formed through their fields. Some examples of our DBMS or relational database management systems are, for example, Oracle database. It's a proprietary RDBMS. It's a licensed product offered by Oracle Corporation. And then MySQL is an open source RDBMS. Microsoft SQL Server, like Access, for example, it is produced by Microsoft. Microsoft SQL Server is a different relational database management system than Access. You have to remember, this is a completely different database than the Microsoft Access. Access is much smaller scale, but SQL Server is an enterprise scale database system. Amazon's Aurora is a database as a service. So on the Amazon AWS, Amazon Web Services, you can use Aurora that actually provides you with facilities of relational database management system. There are many, I mean, there are a lot of open source databases available in market. For example, you have another flavor called PostgreSQL. That is also a relational database system and widely used by enterprises because it's a open source product, and AWS system, they provide uh, they provide the facility to use PostgreSQL. You can have MariaDB, another flavor of MySQL. You can have MariaDB to be installed using some Apache packages. You can have front-end database as well as the back-end database. So what is that? A front-end database is a part of split database that contains the user interface and other objects, but not the tables that are needed for an application. A front-end has a more user-friendly interface than the database management system. A backend database or the backend is a part of split database that contains table objects and is stored on a file server that all users can access. A backend database might include the database server hosting the data, some aspects of database management systems, and database itself. So, when you talk about the backend database, it's more like a core database. The Oracle, for example, you can Oracle is a product. You have a program called Oracle, and then you just store it on a server, and you execute it, and then it you can configure it so that your data is served from that server. So that's a very concrete example of backend database. On the contrary, if you have MariaDB, I mean basically Apache, let me see here. When you talk about Apache XAMPP, it's a front-end database system. In the front end, it provides you with a dashboard, and in the back end, there is a MySQL database. Now, this MySQL database itself can be handled as a back-end database. That's a different story. But when you use the user interface provided by XAMPP, then it's much easier to use. We will talk about XAMPP later. I will give you a different set of information related to the XAMPP because it will be really interesting for you to use that. I want you to know that because this is a very simple yet scalable database management systems, which is basically a manifestation of MySQL, but it uses MariaDB, which is an advanced version of the MySQL, and you can simply do everything that any other relational database management system can do. Specially trained database administrators (DBS) work with the backend components to make sure a company's business data is safe, secure, and well managed. Web developers also distinguish between the front end and back end portions of application development. With large complex applications, some developers will specialize in the back end part, server side, you can say, while some other developers can focus on more on the front end development. Now we can talk about organization of the data. How do we organize the data? So first, the data in a database is organized to allow for a quick searches and to support connections between data and in relationships. Proper setup of tables is one way to make sure that your data is accessible and accurate. Keys and indexes help organize the data more efficiently. So in this connection, you need the indexes. Like I explained before, indexes like the indexes are like exactly like the book's indexes. At the end of the book, you will see that indexes that contains the keywords, and then you have the page numbers next to it. So whenever you want to find a keyword, let's say Java, there's a programming book and you have a keyword Java, then you see there are 5 page numbers next to the indexes. That means that if you go to those pages, you will find some references of Java. So in the database world, index does exactly the same thing. It creates certain paging. It says you that which particular part of your software those values, those attributes are referenced. So an index in a database object that is created based on a field or combination of fields, the index speeds up searching and sorting records in a table. The index on the primary key field keeps constantly updated list of all records in that table sorted in numerical order by those unique numbers. Next comes the primary keys. Each record in a table must be unique in some way. We already explained that. So those, I mean, the primary identification of the each record can be assigned as a number, unique number. That is often called primary key. Sometimes, primary key generation is a little tricky. Sometimes database system can suppose you some sequences that is non-reversible. Like you cannot backward, you cannot like you cannot rewind those sequences. You can only go to the forward direction. That way, whenever a new record is inserted, it is assigned to that forward moving sequence number. Or, I mean, some databases like MySQL or, as I said, the MariaDB, they have the auto increment feature. That means those are embedded in the database management system, so that when you insert a record, when you say that it's a primary key, a field as a primary key, and mark it as auto increment, that means whenever you insert a new record in the database, you don't have to handle by yourself those primary keys. The system will automatically increment that primary key to the next number. So that is also important because the primary keys has to be unique, has to be not null. If the information in a table does not naturally include a field with unique information, the database will assign an automatically generated number to each record. That's what I was talking about. That is unique. So that's the auto increment or the sequence. That's what I was talking about. Then second way to set up a database is to create a table. So first thing you have to define the primary key. You create a table. To create useful database table, the user should start by determining exactly what information the table should hold. Usually the database design is a independent field within the knowledge base of the database management system. So if you have a RDBMS or Relational Database Management System, then database design plays an important role, because in each business problem, you are solving a business problem of storing the data. So in order to store the data in a very organized manner, you have to first identify the main actors of the system, and then you have to identify the main the relationship between the actors. For example, if you have a school database within very high level representation, as I said before, you can have the classes, you can have the sections, you can have the students, I mean enrollments, and you can have the students. So these are the four actors, and then you have to engineer the relationship between them so that you can form a total relational database. So you have to create a table, and you should determine what your student table will store so that it will not contain the redundancies, and it will be easily related with other tables within the database using um, some fields. A DBMS offers different ways to view a table, such as datasheet view, design view, in Access, for example. When you talk about Access, then you can see mostly the two views. One is the datasheet view, another is the design view. The datasheet view shows the table in a grid view with all its field and the records, and it's used to add, edit, and delete records, as well as add, edit, or rename the fields. Since we are talking about the Access, how do you create a new table in the Access? So you have to click the table button on the Create tab on the ribbon to create a blank table. Enter unique field names for the table and make sure to break fields into the smallest logical units. Include at least one field that will be unique to each record. Once the table is set up, switch to Design View. Once all the tables are created, you can establish relationship between the fields and the tables. So these are the brief steps to establish a table in an Access database. So this is a an Access database I have opened. So you click the Create, then you can create a table. So you click here. So a new table named table 1 is created. You can rename it, but you can do the uh, you can add the field. So you can add some field here. Let's say this table is about the student. You can say student ID, and then another field maybe you can say um, student name. So once you are done with this, you can save the changes, and you can say this table to be student table. So you have a student table. So if you see the um, you can have now you can use the forms. You can see here you can have the table design. So under the create you have the table design. If you go to the home you have multiple ribbons there. If you go to the create you have multiple ribbons there. Like this is for the table design, the query wizard, query design, form design, and a lot of other things. If you want to see the design view of the table, you can you can do that. I mean, right click there and you can see the design view. So once you do the design view, it looks like this. The data type is ID is the main the main field, and you have the ID, and it is the auto number. And field one, maybe you can say student name. It's a short text. So you can see the attributes of the short text. It has a size of 255. It accommodates 255 characters. You can say student address. And in place of short text, you can say um, you can mention different data types as well. Long text, let's say. So when you say long text, it is much longer. It accommodates much longer values. You can have date created. So the date when it was created, and you can say it is a date time field. So that can be your student tables basic design view. So when you go there and you open it, um, you can see that student name, I mean student ID is maybe the student name is John DOE. Your student address is 123 Main Street. Date created, maybe you can see the calendar object today, the date was created, and then you can just that's it. I mean, you can simply just save the table at this point. Control S, that will save your table, and now it is available for being used next time. So you can always do the design view for this table. You see what are the fields available in this table. You can open this table and see what are the different fields and how they are oriented here. So in the beginning, we started to do the student name. I mean, those attributes against the ID, but that was not correct. So we had to do the design view first in order to get the representation of the student table, and then we have to switch back to the table view, so that we can enter the data. For example, you can add a new data. So here you can add Jane Smith. So you can see that is auto incremented. Now it is 3, so it is a primary key. Then you can say 124 State Street, and then date created. Maybe it is this record was created on 9th of May. So you have another record, and then you can save this table, and you can finally save the entire database as Access database, and that way you can use it in any other with any other Access system. Okay, so that's the table we have created with the Access database. That's a quick example. So you can create multiple tables in that way, and then you can, once the tables are created, you can establish relationship between the fields in the tables. When you create the database objects, you should consider the following points. First of all, after creating other database objects, the user should be able to extract information from tables and understand the data and the relationship in each table. A form should include all the fields in the table that will store the data in a logical manner and can provide guidance when filling out the form. Queries can be as simple as finding all records that meet certain criteria. A well-designed report will be easier to read and look professional. Now let's talk about database integrity a little bit. Data in a database can be more vulnerable than data in a file processing system. Managing a company's database requires a great deal of coordination. The DBA is the person in the organization who is responsible for management and coordination of all database activities. The DBA is also responsible for security, the data security, and also the maintaining and backing up the database and protect its data. Many programs perform validation check that analyzes the data. Validation techniques include, for example, alphanumeric numeric check. It can do the range check, what is the range of the data, the values, the consistency check, then the completeness check whether everything is complete, the digit check, check the digits, check the data type, uh, presence check if the data is there or not, the field property can be checked, it can check for the uniqueness, it can check for the format. Let's say you are entering some date, the date can be of different formats within different systems. So it can you can initiate a date format check, and also the multiple choice check. You can do that as well. So Access database system provides an input mask wizard that actually enables all the checks. The valid data and invalid data can be like validity check when you say the alphabetic check. So the city name, if it contains some numeric field or some special symbols, then immediately the system will tell that this is an invalid data. Now you can have the numeric check on the database as well. You have the current enrollment, and then the valid data is the numeric, but if you put some text there, then immediately it will be invalid, it will be invalidated. If your sample, if your data is not satisfying the range, let's say per credit hour fee, your valid data can be this one, invalid data can be that one, so you can validate it against a range. Consistency check, for example, you have the date admitted and birth date. So uh, this is a valid, I mean, date admitted is, let's say, these dates can be this type, but I mean, your date admitted must be after the birth date, right? But invalid data is this one because someone has been admitted before their birth date, so it's not possible. The completeness check, you see the last name, it's there, but then the last name is not there, so this is incomplete. Other check, for example, email address is like that. So you can have an email validation enforced within your RDBMS, and then you can see that this one is in an invalid data because this does not have the at the rate sign at all. There can be other invalid email format. So that's why the database by itself provides you some validation uh, validation logic. Now, if this is good for the front-end based database system, like Access, it has a strong front end, but there are some databases like Oracle, for example. It may not, you may not, you can use it as a bare metal, the core, the back end. In that case, the application that you are writing, you have to put that application in action to validate those fields. Sometimes people use the constraints to do some validation, but rather than using the constraints, you can use your application to validate the data fields. But basic validation like numeric versus characters or dates, that should be mandated by the types, data types specified within different fields. These are the this is a list of the best practices in the database security. First of all, users given access to the database should have a profile that includes a long, secure password for their account that must be changed periodically. So the password change logic should be playing inside the DBMS. Web servers are designed to be accessible to the open internet. Sensitive data in a database should be encrypted. Social security number, for example, or password, they should be encrypted. There is a very common way of representing the passwords. You can always hash the password. Hashing is a specialized, I mean, it's a kind of encryption technique by which you can make the password field to be non-guessable by anybody. Limit the number of unsuccessful sign-in attempts in a specific period and record when user access the database. So basically audit the sign in and sign off activities. And if there is any unsuccessful login, then you can limit, like if there are more than two unsuccessful login, you might notice that some of the databases, like for example, if you're dealing with financial databases, credit card company or banks, they may lock your access. So that can be done at the database level itself. But that's a not good idea if you are a developer of the system and you are developing at a odd time, let's say in the midnight, and then your database is suddenly locked. You are locked out of your system and then you cannot continue working. You have to wait until the DBA comes in the office and does that for you. The database maintenance starts as soon as the database is installed. The maintenance starts immediately after its creation and it lasts as long as the database is used. One of the primary maintenance concerns is limiting the size of the database by including only the records and data that are currently relevant. If the database contains large number of records, consider deleting records you do not need. So in order to address that, it's not very obvious as I am saying it here. Many enterprises, many organizations, they establish some sort of uh, data retention policy because of the legal uh, constraints. You cannot just delete the data as you wish, or just to free up your database. You cannot keep freeing up the data. You have to take a backup some way so that those data can be retrieved in the future. There is a popular way of taking I mean, popular way of data of not using the current data is to maintain a history table. I mean, there are tables like normal table, and you can create a table with a suffix of history for that particular table. That way, actually, you can store the legacy data, I mean the old data there. So long as you don't access those tables from your application, you should be good because history data, for example, they can contain the data up to last 10 years, and that will be a huge data volume. So if any part of your application, any query accesses uses those history database, your performance will be substantially degraded. So you have to make sure that your applications don't use frequently for the history data. They can be stored just for troubleshooting purposes or reference purposes or any legal requirement purposes. There is another important aspect is backing up and recovering a database. The backup process for a sizable database is not very simple as creating a second copy of the database file. Database can be restored using the backup files. This recovery process might be applied only a single object or record or to the entire database, depending on the situation. This process is usually performed using a recovery tool. Every database vendor provides you with a specific recovery tool, which can be a part. I mean, this is part of the DBMS distribution. You can protect the data in many ways. You have to ensure that data is accessible when it is needed and no one has made unauthorized changes. So these two things are the key aspects of the database security. So you have to restrict the accessibility of the data to uh, whenever is needed and whoever is authorized. You know. Also, you have to prevent the unauthorized changes. A classic security model called confidentiality, integrity, and availability triad addresses this concern directly. They call it CIA. You can see the confidentiality. So, and you have the availability and you have the integrity. So these three constraints are maintained. If they are maintained, then you are supposed to, then you can, then it can be assumed that you are maintaining the database in a very secured way. The triad that we described, the CIA, um, the confidentially, what is the confidentiality? This is the need to protect a database from unauthorized access. So it should be confidential. Integrity means protecting data from unauthorized changes. And then availability means we need to ensure that when the data is needed, it should be accessible. Like any other topics within this course, the introductory concepts of the computer and its uses, the domains around the computer, ethics play an important role. The large and complex data sources that defy traditional data processing methods are called big data. All the web activities generate and interact with the data that is stored, analyzed, and referenced when making business decision. Some example is uh, big data example are data streams for the Internet of Things devices that monitor a passenger plane's engine performance, changing ownership and valuations of stocks on the New York Stock Exchange, and so on. Now, big data is often described according to the three V: volume, va- variety, and velocity. Now, two additional V's often used to describe big data, that is value and veracity. So there are a lot of V's in terms of the big data. Three V's are volume, variety, and velocity. And your additional V's, two V's are value and veracity. The way in which businesses generate big data is by capturing customer behaviors. You know, we are moving towards the ethics slowly, but stay tuned. Amazon and other retailers compile data from customer purchases in a process called collaborative filtering to recommend related products. Government agencies generate large amounts of data in real time from satellite images, social media posts, and other media. The analysis of big data benefits businesses by providing a bird's eye view of how well the business is functioning and giving insight into how to improve the business processes and increase productivity. The business processes and technologies used to do this analysis are called the business intelligence or BI. In a BI system, you are basically define some key performance indicators of certain business processes. You can define a business process like uh, the design of the course design within the college infrastructure, and you can define certain KPIs, I mean key performance indicators, how how that course is evaluated by the students, I mean how that course structure is evaluated by the student, how is it presented, and how much benefit the student community gets out of that course. That can be three important KPIs for a course design. There can be others like how the course is meeting some general requirements like accessibility requirements, or how the course is very specific to the actual um, actual subject that is taught. For example, if you design a course in computer science while in you are teaching, your main topic is some legal, that may not make sense, right? Some law course, you are designing a law course, but you are including a lot of computer science material, that may not be very sensible. Nobody does that. So that's an example. I mean, that's business intelligence can quickly find it. I mean, those are the test cases, very wide test cases, very detectable test cases, but there are other stuffs as well, like those accessibility issues, and also the expressiveness, the information enrichment, and also the engagement, the emphasis on the engagement, how the modules are designed, how engaged that modules make the students. Lot of subjective, lot of objective factors can play a role. The business intelligence system might collect data from existing databases and from live data streams into central repository called a data warehouse. Another option for BI system is a data lake, which is a collection of both structural and structured and unstructured data. So a classic example of data lake can be a simple file system. You know, in a file system, you can store access database. So you have an access file which you can restore into an Access database to see the relational view of the data. And then you can have some flat files, I mean simple comma separated value files, which is a kind of unstructured data sometimes. Or you can have not CSV, like some flat files, some let's say the Twitter messages of different people. That is an example of unstructured data because you don't know what that person is going to write certain times. After data is summarized and analyzed, it is often presented to decision makers in a dashboard that provides at a glance views which with live updates as data continues to pour in. Emerging patterns and insights from these data analytics processes help to inform business decisions and strategies. So we can do a case study like for example uh, Octave Clothing's database stores information about its customers, including name, address, and phone number, email address, and order history. While reviewing the database to ensure data integrity, the manager noticed that some of the postal codes, which should be a minimum of 5 digits, are only 4 digits. Now, based on this situation, what might be wrong with the data? The field values are not set or validated, number one. Number two, customers forgot to add a zero to the postal code. Number three, all customer messages and promotions are communicated digitally, so postal codes are not required anyway. Number four, data was entered wrong while entering the forms. Entered while entering the forms. So these are the four options. Which one is the correct? So this can be a result of the field values that are not validated. So that emphasizes the importance of field validation. So this is the correct answer because you can enter some field to be wrong um, to the database. You can attempt, but if your validation is correct, then you should not be able to enter that data. Yeah, that's the right answer. Now, as far as the self-assessment goes, I would like to ask you three questions. What points regarding using data responsibly stood out to you as most important based on this discussion? Number two, which concepts about databases and data storage did you find difficult to understand? And number three, have you used a program to create a spreadsheet or a database? Did you use the Excel spreadsheet? What program did you use and what functionality did you employ to manage your data? So these are the three self-assessment questions. Try to come up with some answers that will give you a lot of insight into this subject matter. With that, I think we have reached to the uh, end of this presentation and this discussion. So if you have any questions, don't hesitate to reach out to me. Thank you.